Good day everyone, I am Dellosa and I'll be presenting our research entitled Growing Plants in Salt Water Through Hydroponic System. According to YADA et al. 2023, soil provides essential nutrients that plants need to grow. Without these nutrients, plant growth would be stunted or impossible. Most of our food is produced by plants that grow on soil. Producing nutrient-rich crops that support human and animal life requires a healthy soil. However, some research suggested that nowadays the traditional farming system does not meet the current and future demands of food. Therefore, there is a real need for adopting a new farming system that stimulates plants to grow, and that is hydroponics. Hydroponics, plants are grown in a nutrient-rich water solution without the use of soil. Researchers like Barrett et al. From 2018, they contend that effective and ecologically friendly materials for growing media must be identified in order to guarantee the growth and sustainable development of soilless farming. Soilless farming has a lot to offer as a truly green industry in a world where resources are becoming increasingly limited and the weather is unpredictable. It uses renewable resources, minimizes waste, and increases crop productivity and efficiency. The statements of the problems are to look for the viability of growing a variety of plants in saltwater conditions, applying hydroponic system, to ascertain the ideal fertilizer and mineral supplementation needed for plant growth in saltwater-based hydroponic systems, to evaluate the effects for various salinity levels, including those typically seen in coastal and desert locations on plant growth, to identify specific plant species that are particularly well suited for cultivation in saltwater-based hydroponic system and assess their commercial potential, and lastly, to evaluate the potential for recycling and purifying saltwater within hydroponic systems to reduce water consumption and environmental impact. This study has significant benefits to the following. The Bughaw City DENR or Department of Environmental and Natural Resources, because determining the efficiency of hydroponic system among the researchers of the community to provide data which may help sustainable agricultural and environmental conservation efforts. To the farmers, these benefits collectively enhance the sustainability, efficiency, and profitability of farming operations, making hydroponics a compelling and significant choice for modern agricultural practices. And for the future researchers, the findings of this study can be used as a guide for the future. Scope and limitation. The goal of this study is to use hydroponic system to grow plants in salt water. It restricts the following elements: plant choice, hydroponic methods, environmental influences, time frame, geographic variations, and outside influences. Conceptual framework. The input: water quality and environmental conditions, growth and yield parameters of aquacultural and hydroponic crops. The materials are pipe, saltwater gallon, and pump. The process is data analysis. The growth and yield of eggplant, chili, ladyfinger, and onion. The output is the system design, growth response, yield response, water consumption cell. The review of related literature. According to Torres et al. 2020, vegetables and flowers have been grown effectively using hydroponic method of crop cultivation. It was discovered that there are many instances of successful experiments. Nevertheless, there aren't many full-scale examples. The production of legal cannabis and recent interest in vertical farming have raised interest in hydroponics, and the use of RW as a nutrient solution may now be financially feasible. Materials and methods. Salt water. Create an environment suitable for the growth of salt-tolerant plants. Pipe. Transport the nutrient-rich water to the plant roots and return any excess solution to the reservoir. Water pump. Circulates the nutrient solution through the pipes and delivers it to the plant roots. Data gathering procedure. After getting the permission from the school's principal, we then make the prototype. After making the prototype, we go to proceed in getting the salt water at the Younger Philippines. Results are as captioned. Table 1, plant name, their color, and sizes and height in centimeters. Solana melanogena eggplant, 5 cm, grow up to 9 cm. Capsicum frutescens or chili, from 9 cm to 13 cm. Abselmochus esculentus or ladyfinger, 11 cm to 14 cm. And allium cepa or onion, from 2.5 cm to 4 cm. These are the results of the study. The summary, recommendation, and conclusion. Summary: growth dynamic of plants. The chosen plant species showed vigorous growth patterns, which was unexpected. There was no discernible barrier to total plant development as compared to conventional hydroponic systems, indicating that salt water can be a useful medium for long-term, robust plant growth. The results of the analysis of nutrient uptake efficiency showed that plants' growth in hydroponic system using salt water exhibit exceptional flexibility. The plant successfully collected critical elements from the saltwater solution, indicating that employing seawater as a nutrient source is feasible. The nutrient absorption rates were determined to be within acceptable norms. It shows how promising this novel strategy might be. These results open the door for more research and development of hydroponic systems that use salt water as a resource for plant growth, adding to the expanding body of knowledge in suitable agriculture. Recommendations: optimization of composition of nutrient solutions, species diversity in plants, extended duration environmental impact evaluation, investigation of plant traits resistant to salinity. The conclusion, the study investigates if hydroponic saltwater systems are feasible for plant development, providing potential answers to the world's agricultural problems. The results show that by improving growth rates and reacting effectively to salinity stress, this novel strategy outperforms conventional techniques. The effective uptake of nutrients by the system increases cultivation opportunities and fosters the agricultural diversity. Hydroponic saltwater farming is a resource-efficient and ecologically responsible technique that has the ability to address climate-related issues and form a sustainable agricultural future due to its promising yields and decreased dependency on fresh water. And that is our research. Thank you.